My lecture today is called Push and Convey, but before I really explain what that means, I want to go set a little bit of context and explain to you who I am and what I do. So, I'm an independent game developer. I've been one kind or another of independent developer for about 12 or 13 years now, which means I mostly fund my own work. Once in a while that happens by doing consulting projects for larger companies. But most of the reason that I exist professionally is to work on my own projects. My current project is a game I've been working on for 3 years. It's going to be published pretty soon on Xbox Live Arcade. And it's a 2D platformer game. And I don't want to do any kind of time-consuming demo of it, so I'm just going to flip through some screenshots and explain to you what this game is. As you can see, well, hopefully the light levels are good. Can we turn it down a little bit more? Thank you. Okay, so as you can see, it's got a very painterly style to it. This is the title screen. It's a scrolling game, so as you walk off to the right, things will scroll in parallax. We cared a lot about the mood and the feel of this game. You journey from world to world, and the worlds have different themes, and you maybe run and you jump over gaps and jump on things and solve puzzles. Some of the puzzles are pretty complicated, and you can solve them by bouncing off things' heads in the style of classical games like Super Mario Brothers. And in this screen, I'm trying to collect that puzzle piece that's in the top middle there, and after I collect all of those, I can complete the game. And it's also got some story elements that help set the mood and help create analogies between the gameplay and the fiction. So you probably noticed, hey, that's very two-dimensional. A lot of people who want to start to make an impressive or important game would make a 3D game. Why did I pick 2D? There's many reasons, but the two biggest ones are that the design of this game was very challenging, and maybe I'll get more into why later, but I wanted to focus on the design and do something really important and effective there. And I have a history as a programmer, and I knew that if I tried to start building very complicated technology, I would get bogged down there. So I didn't want to be 3D, I didn't want shaders, I wanted very simple technology. So I could focus on the gameplay. And as it turned out, there were enough difficult programming tasks in this game to keep me busy, and I was programming most of the time anyway. So I'm very glad that I made that decision, otherwise I don't know how the game would have come out. And the second reason was to enable a human-feeling art style. The budget for this game was not that big. I ended up spending a lot more than the original budget, but still, for the amount of money that I spent, you can't buy high-end 3D graphics like you might have in a game like Gears of War or Halo 3. Those are very, very expensive and require a lot of man-hours. And if you try to do that insufficiently, as an indie or as a student with a small or no budget, what you get tends to look kind of, simplistic and maybe ugly. It certainly isn't what you would ideally want. And I wanted this to be a very emotional game. And the way to get that, the way to make it feel human, was to go 2D and have hand-drawn art rather than something cranked out of 3D Studio Max. And we'll come back to these later, but I just wanted to put that out there so that you kind of understand what's coming up. My interests right now, as a professional, are to create games that are meaningful to people. And by that I mean not just fun, right? A lot of games can be fun, and that's nice. But I want to make games that can affect people and inspire them in the same way that perhaps you might read a great novel and it might change your life in some way. I want to create experiences that are mind-expanding, and I want to push the boundaries of what a game is. I think that if we work hard on this medium and do a lot of experimental work, eventually we can push it to a point where these interactive experiences that we create, which will be very compelling, are very different than what we have today when we think of the words video game. And I think that'll be a very interesting time, and I want to get there. So, to start off, I'm going to talk about creative skills that we use to make games. The ones I'm going to focus on today are programming, design, and art. And I have art in quotes. I don't know if there's a different word for it in Danish, but in English, when we talk about game development, this refers to visual art, like either drawing images or texture maps, or building 3D meshes or animations. And I have it in quotes because really all of these things can be art, right? Good game design is an art, determining what the game is about and what will affect people, right? And how to do it. Good programming is an art, right? It's like architecture. It's building this very sophisticated program and being creative about how things are put together and how things flow from place to place can be very artistic. So I chose these 3 tasks because these are the things that you most readily think of when you start making a game. They're obvious, like programming produces something tangible. Code, design produces something tangible, rules of the game, etc. There are other roles in game development that are important, like quality assurance and marketing and production, but I'm not going to talk about those today. So, because these are so tangible, they get a lot of attention, right? You might study these subjects in a school like this one. You might be hired into these positions for a job, right? Wanted game programmer. If you're an independent developer, you might end up doing all of these things at once because you have a very small team and everybody needs to play multiple roles. In the game that I showed you, I did all the programming and all the design and some art direction. And the artist, David Hellman, who drew the stuff in that game, is actually independently motivated enough that he was able to do a different portion of art direction and be significantly responsible for the way the game looks. So I didn't have to do all of that, thankfully, but I did some of it. So even though we have different terms for these things, and when you think of them, when you think of programming, you think of something very different than when you think of design. But they're not orthogonal, right? By which I mean they overlap to a significant amount. And there are obvious ways that happens and non-obvious ways. And because I'm cramming as much material into this lecture as I can, I'm just going to go straight to the non-obvious ways. So I have 2 here. The first one is that design can significantly impact your art. Like what the artist can do, should be permitted to do maybe, in order for the game to look good. In the game that I showed you, right, it's a puzzle game where the puzzles are very difficult. So you spend a lot of time looking at the screen. I'll flip back to a screenshot of that. You spend a lot of time looking at the screen thinking, how do I solve this? What directions can I walk from here to get up there to the top? And how... This doesn't actually look like a puzzle. This is maybe a bad screenshot, but it's actually a really hard puzzle. How do I get up there? And, maybe I go to the left, maybe I go to the right, maybe I climb these ladders. You need to be able to look at the screen and understand what your options are, right? Without spending a lot of brain power on that. Because I wanted your brain power to be focused on the point of the game, which is experiencing and solving the puzzle. I didn't want you to spend it disambiguating the foreground from the background. I didn't want you to spend it trying to wonder, how far out on this platform can I stand before I will fall, right? Or is this a jump that I can make? Or will I, not quite make it across the gap and fall in? Here's an example of that. You can see that the platforms on both sides of this player are very crisp, right? You can see exactly where they end. And that was a clear design decision by the design requirements of the game that impacted the art. There are some more subtle ways that happened in this game as well. I'll flip to one down here. As I said, I wanted this to be a very emotional game, and one of the things I wanted to achieve was a sense of vagueness, a sense of impermanence, and that things are changing. Unfortunately, I'm not running it right now, but if I were, you would see that splotches of color are sort of fading in and out of this scene. But that aesthetic design goal, in some sense, almost conflicts with the concrete design goal that this has to be a functional platformer that doesn't confuse the player. So, the way to resolve that was to set art guidelines. And the guidelines we came up with was, anything that comes close to the player's feet or head, anything that you might collide with, is drawn at a high level of detail. So all these surfaces, like the top of the foreground grass and these platforms, are all, every pixel we cared about there. But as you go deeper into the ground and off to the side, the brush strokes become, bigger and more coarse. And that's how we establish this feeling of vagueness and of, a gradient of detail across the scene without impacting the gameplay. This carries over into some other elements. So if you notice the background back there, even though the palette is not necessarily that far from the foreground, it's pretty obvious what's the background. And the reason is that the colors are a little more desaturated, and there's no high frequency detail back there, and there's no high contrast back there, right? These are all art decisions that we made, not just to independently create some art aesthetic, but to make sure that was compatible with the design goals. So that's just what I'm trying to say, is that art doesn't happen in a vacuum. It's not like somebody decides what the game looks like and then makes it look that way. So here's another one. that's maybe even less obvious, but people who've done a lot of game work will recognize this immediately. Programmers end up doing game design all the time, even though people don't really realize it. And the reason is that designers never specify the game down to some level of detail that tells you everything you need to know to implement it. The programmer always needs to fill in some gaps. One example is, this is a platformer game. If I'm standing still and the player moves the joystick, I want to start running, and I have some maximum run speed. And you don't just want to go from speed 0 to maximum run speed, because that looks very jumpy and it feels bad, right? You want your character to accelerate. And when you let go of the joystick, you want him to decelerate back to stopping. But you want to be very careful about those values, because if you take too long to decelerate, the guy will skid, and the player wanted to stop at the edge of a platform, but he just skidded off and fell, and that makes for a very bad game. So the designer might say, well, I want it to take 0.2 seconds to accelerate to full speed and 0.1 to go back to stopping. But that's not enough to implement it, because there are a lot of different ways you can accelerate or decelerate. And if I'm the programmer, I have a decision to make here, right? I could say we're slowing down the character. I could decelerate him by every frame that the joystick isn't being pushed. Then I'll subtract some constant amount from his velocity, right? This delta v, and eventually that'll go below 0, and I'll clamp that at 0, right? That gives you this very linear slowdown, right? That feels a certain way. But I can also do a more physically oriented thing and say there's going to be this coefficient of friction, mu, and as I slide along this surface, right, I'm going to multiply the velocity by that, and as it gets below some, coefficient of static friction, then I'm going to stop the guy, right? And make a physics problem out of it. That has a very different feel, because instead of creating a linear slowdown, it creates this curve that starts dropping off quickly, but then stops dropping more slowly, and it might feel more organic, and also allow the character to slide less. And which decision is right depends on the game, right? But designers don't even necessarily, depending on their training, have enough mathematical thinking to even realize that there are different options here, right? They don't often go to that depth. And so the programmer will make that design decision, and maybe the designer will say, oh, this isn't what I wanted, it doesn't feel right, let's talk about how to do this differently. But much more often than that, what happens is the designer just doesn't notice, or he has too many other things to think about, and then it just stays as whatever the programmer decided. And so all these things are intertwined. But despite the fact that they're intertwined, and despite the fact that they get all this attention, they are what I'm going to call surface skills. By that I mean they're obvious, but there are a lot of things lurking beneath them that are perhaps more important. And I'm going to isolate two of those things today, which I call guiding skills. And this term guiding skills is something that I just made up, so you can't search for it on the internet about game development and find anything, unfortunately. But these are skills that are not taught in school, and that nobody will ever hire you in a job for this position, but they're skills that everybody needs to have in order to be successful at high-quality game development, right? You can develop a low-quality game. Anyone can do that. But if you want to make a great game, how do you do it? And so if you don't have these guiding skills nailed down, then those surface skills will be misdirected, and the game will miss its potential. So if you are a really good programmer, but you're not programming in the right direction, then you'll get a game done maybe pretty fast, but it won't maybe be a very good game. And then what was the point of getting it done fast if it's not very good? If you're not a mediocre or bad programmer, but you have very good guidance skills, you'll get to a really good game eventually, but it may take you longer. But that's okay, because you get there. So, and the reason why I want to talk about these things now is not, it's not a totally abstract reason. The past couple of weeks, myself and some friends of mine have been judging a bunch of submissions for this event that we do called the Experimental Gameplay Workshop at the Game Developers Conference every year. And in this workshop, we put out a call for participation where we say, hey, everybody out there working on games designs that are new and experimental, tell us about your game, and we'll pick some that'll come to the show and give a 15-minute presentation to a wide audience of professional game developers. So we're looking for really avant-garde stuff here, but also stuff that isn't just a wacky idea, but that has been implemented and works, right? And year after year, we see the same problems over and over, both from academia and from independent developers, and sometimes even from professional developers. So what I'm going to talk about now is motivated by seeing the same problems over and over and asking ourselves, well, what exactly is wrong here? How do we diagnose this and tell people what they're doing? Okay. So these two guiding skills, again, I've had to make up names for them because nobody talks about them in concrete terms. So I've called them conveyance and pushing, and I'm going to explain those one at a time. Conveyance is the process of connecting the game from inside your mind out to the audience, right? When you set out to start game development, if you're a designer, or maybe you're a programmer and you've read some design doc, there's some image in your head about what that game is going to be. And it's this great thing. It's going to be like the coolest game ever, which is why the star is just so shiny. And you've got some audience out there that's waiting for your game, and they're really going to enjoy it when they get it. And you have to connect that now, right? So the process of game development is implementing things, right? Programming things or drawing art or whatever that will connect from this imaginary thing inside your head out to reality to where your audience can get it. So this is the ideal, right? In the ideal world, we do a great job of development and we do everything properly, and all these lines neatly connect and our audience gets everything that we want them to get. But that's not usually what happens in reality. This is what usually happens, which is maybe a couple of those arrows make it or sort of make it halfway, but then a lot of them just go in the wrong direction and some of them just don't ever get out of the head. Sometimes this is due to concrete development problems, like we had problems programming this system, so we had to cut this part of the game because it was taking too long and had too many bugs. But there's a subtler problem, which is that it takes a certain kind of skill to understand when you are meeting your design goals, right? When this thing that you're programming is going to be understood by the user, right? When this thing that you're drawing is going to be seen the way that you want the audience to see it, right? It's easy for you to imagine how the audience is going to see it, but is that imagination coinciding with reality? So, I struggled for a while to try to come up with a way of explaining these problems without resorting to criticizing people's games, because all of the games I'm going to talk about here are forward-thinking games that I respect tremendously, but at the same time, I couldn't find a way to talk about these problems in a way that I thought people would get it without focusing on specifics. And so, as a kind of compromise, I'm trying to pick only games that I really like, so that you guys out there know that I'm not here to just slander game developers. But at the same time, I'm just going to start picking apart problems in them, right? So here's Space Giraffe, and it has a severe conveyance problem. It's a great game. It was one of my favorite games of last year on any platform. As you can see, there are a lot of trippy colors going on here. It's a game like Tempest, where you move back and forth in the near field and shoot enemies that are coming toward you. People sit down and start to play this game and they say, I can't see anything, right? I'm getting killed by these bullets coming out of nowhere. I don't understand what I'm supposed to do. This is kind of ugly. What's going on? And they start thinking that after about 2 levels of the demo, and then they quit the game before they ever even really understand the game. And that's not the player's fault, it's the designer's fault, right? So Jeff Minter, the author of this game, doesn't have good conveyance skills, right? The game does not communicate itself effectively to the player. There's a tutorial at the beginning, which also, now the tutorial tries to explain the concrete game mechanics, like here are the different moves that you can do, here's what the enemies do, but it doesn't even do a very good job of that, and the player just comes out of it confused, thinking that you're just supposed to kill these guys as fast as you can. And if you play the game that way, it's really tedious and not fun. So that's a failing of the tutorial. But another one is that he never explains a big part of the aesthetic point of this game, which is that, there's all this crazy light show going on, and as you go through the game further and further, it gets more and more imposing till you think it's almost impossible to see anything. But your brain is magical, and you can learn to see it, and you can learn to play within this light show and do, really tremendous things that onlookers would be like, how are you even playing this game? It's a mess. Like, that is a big part of the point of this game, but nobody knows it, right? Almost nobody, because the game doesn't communicate it, right? So this was a game that was developed with competent design, like good design, I would claim. I love the design of this game, but poor conveyance. So nobody knows how good the design is. Now, the interesting thing about conveyance is that, as I've said, you sit down in front of a game, you start playing it, and you're learning the rules as you start to play, right? With anything, whether it's a complicated game or a simple game, you're seeing the way things interact. You're like, oh, when I walk in front of this object, it activates and starts animating. Maybe that means I can use it, right? You start to make inferences about the game world and how it works. Now, the interesting thing is that some games that are coming out recently do a very good job of giving you a payload primarily through conveyance, right? And my primary example of that is this game, The Marriage by Rod Humble. It's an art game. The reason why I said the game giving you its payload is because I'm trying to imply that games can have a lot of different reasons for existence, right? I'm implying that a game wants to express something to you, but maybe it's not fun or excitement, right? If you have like a survival horror game like Resident Evil or something, maybe the payload of that is feeling scared and exploring a scary place and fighting monsters once in a while. But in this game, The Marriage, the payload is that the author wants to tell you what it feels like to be in his marriage with his wife. And the way he does that is through rules of the game that he doesn't tell you what they are when you start. So you start playing this game, and you've just got a mouse cursor, and you move it around, and you notice that things react to where you put the cursor, and you start to understand the patterns, and then you start to interpret the patterns, right? So you say maybe, at least in America, pink is a stereotypically female color and blue is a male color. So you think, well, this is probably the husband and wife. And when I move my cursor over one of them, they move back toward each other, so maybe they're getting closer. But when they spend a lot of time together, the woman gets bigger and the man gets smaller. So maybe this, and maybe that represents their egos or something, and the guy wants to get away and go explore some of these things out here, and he gets bigger again. And you really, and it's a much more intricate game than that, right? There's more to it, so I don't want you to think it's like that one rule. But you start playing this game, and you really start to understand what he was trying to say simply through this process of conveyance that I was talking about before. There's another game which isn't really an art game except maybe just in the name. It's called Mr. Hart Loves You Very Much. This was made for the Gamma 256 Games competition a few months ago. The theme of that competition was that games had to be pretty low res. They had to be 256 by 256 or below. But there were no creative constraints. And I really like this game because it's very simple, and because it's so simple, it highlights to an extreme degree this process of conveyance. All games these days, or most games, have a tutorial at the beginning that teaches you, but this game does it so simply and beautifully that I'm going to demo it for you right now. I think it won't even turn the whole screen. Yeah, it's not. As you can see, it was made kind of quickly. It doesn't play that well with Windows even. But I'm going to press Start to Play. And it just drops you into this level. And I'm like, what's going on? I can use the arrow keys, and I realize that I'm this little green guy. And there's really nowhere for me to go here, except to the right where this heart is. And I go there, and I won the level, right? That wasn't a challenge. Wait, aren't games supposed to be challenging? But no, the point of that level was to teach me, without having to read instructions, the point of this game is to get from the beginning to the heart, and go on to the next level. So here, it's the same kind of thing, except now there's a gap in this hallway that wasn't there before. And I'm like, what is this about? Well, wait, I don't know if you can see this back there. I guess you can, but most of these hallways have an orange border around them that kind of looks like a wall, except for around this gap where there isn't one. And that makes me think, can I go there? Like what? Oh, wait, if I go there, I can move this piece around. That's interesting. I don't even know if I would have explained that if I would have understood that if you tried to explain it in words. But in gameplay, it's so simple. You touch the wall and it moves. You touch the wall and it moves. I can move this block around and get the heart. So in this time, the clue comes in the level name. R is for rotate. I can't push these things because there are other blocks in the way, I guess. And this heart is up. Up arrow doesn't make me jump. What do I do? But he said R is for rotate, so I can try rotating the level. And there we go. And so these aren't really puzzles yet, right? But despite the fact that they're not challenging, they're interesting to the player because I'm seeing new things. I'm learning new things as I proceed through the game. So it doesn't have to be challenging yet, even though it's a puzzle game, right? So level 4, this is the first time where you maybe combine some of these skills, right? Like, oh, what can I do? I see that there are these gaps in the orange that I can probably travel through. So what if I, kind of slid over here and then I rotate, and I can kind of walk and connect that, and I don't actually remember how to solve this, but yeah, it's pretty simple. So I'm just going to rotate this way and win, right? And from there, so this is the first puzzle where it starts to actually be puzzles, because that's all the game mechanics, right? It showed you each one at a time, and then it shows you how they combine together, all in something that's not hard to figure out. And now here's something that's a little bit challenging, and I'm not going to spend time playing through it. It might take me a while to remember, but yeah, so that's really cool, and that to me highlights an ideal of what game developers should shoot for. Like, it should be intuitive, but also compelling. Like, I play so many games that have a really boring tutorial at the beginning. I'm like, I just want to skip through this and get to the real thing. That was the real thing, but it was also teaching me about it, right? That's very cool. Okay, so there's an inverse to this process also. So conveyance that I've been talking about, forward conveyance, is about going from the idea in your head out into the world. There's also one about going from things in the world back into your head. I don't know if inverse conveyance is the best name for it, but I couldn't think of a better name on short notice. This is something that you do during the game development process. So before, I was thinking of a game as an exercise in communication. You're trying to communicate things to your audience, and that's what all those arrows were. Now I'm going to think about it as an object that you're constructing in the world. You're building this game, and because game development is hard, right, you might make mistakes sometimes, or things might not come out the way that you want. And so you need to be constantly looking at this thing that you're building, right, and making a mental model of what this thing is actually, right? What is the progress of it? Which parts are working, which parts aren't? And then compare that mental model to the ideal, that glowing star in your head, and say, how good of a job am I doing? Is this on the right track or isn't it? And that sounds really obvious. Well, of course, if you're working on something, you're trying to bring it toward the goal. But it's so obvious that people don't think about it enough and screw it up all the time. And this is one of the major mistakes that we see. So a way to paraphrase it that somebody emailed me is that it's very easy to make your game run well inside your head, but that's a different thing from making it run well in reality. So here again, inverse conveyance. I've just got this shining star on the right. This is the ideal version where I've built this game perfectly, and then I'm looking at it and I'm building this model of it in my head, and I'm going, oh yeah, this thing that I see in reality matches exactly what I wanted, and I'm happy, right? But what usually happens, actually, is this thing that we're making is kind of messed up and not really what we want. If our inverse conveyance skills are working well, then we build that same picture in our head. But what usually happens is that our inverse conveyance skills are not working well, right? And we do things like think, okay, the game that I wanted, it was this white colored star that was glowing, and it was a 5-pointed star. And you look out and you're like, yeah, I really want my game to be successful. Well, let me look at what I've built. Yeah, it has 5 points, I guess, and it's white, so I must have succeeded, When in reality, this thing is really messed up. Not to rag on academia and people too much, but we see this all. This is the number one thing that we see coming out of people in higher education trying to do game work. But really, everybody does it. So I don't mean to single them out, right? Indie developers do it. Students do it. Veteran pro developers who have 10 games under their belt do this all the time. Anyone with a lot of game development experience will know it's a very common situation. You've been working on a game for a while. You've tried to anticipate all the problems your users are going to have. You polish all the beginning levels and you worry about all the game mechanics, and you come to a point where you think your game is ready to be played. And then you go bring it to have some people play it who don't know you. They haven't heard of your game before. And you don't try to guide them through the game, right? You just sit them down in front of it. You don't say anything, and you just watch them, right? And they start to play the game, and almost all the time it's a complete disaster. Like they're confused. They start getting stuck on things that you didn't even think about, because they were so obvious to you, and your player's having a horrible experience for reasons that you never even imagined, right? This happens to veteran developers all the time. And so what happens is after making enough games and after seeing this kind of, bad player reaction happen, we learn to build this inverse conveyance skill by mistrusting our own faith in how well our game design is coming along. We'll make our next game and we'll say, yeah, I think this is going pretty well, but the past 7 or 8 times it actually didn't go as well as I thought. So this time it probably isn't either, right? But that's an acquired reflex. Like, people naturally have a very gracious view of their own products. They really give them the benefit of the doubt. And you have to work to get around that if you really want to be successful at making a quality game. Again, I feel horrible picking somebody's name out to demonstrate this, but it's the only way. This is Utopia by Santiago Siri. He's a guy who's somewhat well known in art game circles. He runs a blog that some people read. He lives in South America somewhere. This game was a submission to the Experimental Gameplay Workshop. It has never been released, so you can't download it. As opposed to that Mr. Hart game, which is downloadable, and I encourage everybody to go download it and play it. This is a screenshot. It's not a running version of the game. But it's a very complicated game about building societies around some ideal of your character. And one of the core things about this game was it was going to have good AI in all the characters, and it was going to have generative story based on what the AIs do. And the way that you interact with these AIs was going to be through dialogue. Most traditional games have dialogue trees, right? If you think about an old adventure game, you can say hello to the guy or ask him where the bathroom is, or you can say an insult to him. And there's a limited number of choices that the designer had to determine in advance. And here, he has a limited number of choices, but he was at least trying to open it up a little bit and allow you to say things in an analog manner to allow the AI to have analog responses. And the theory would be that that creates a much richer set of potential behavior from the game. So this box down here below the character's face, who's a female, has 4 quadrants. Actually, let's talk about the axes. There's a horizontal axis, which if you click somewhere on the left-hand side, that means you're having a very emotional reaction to this player. And if you click on the right-hand side, it means you're having a very intellectual reaction to the player, right? And then if you click down toward the bottom, you're signifying that you want to make a very negative response. And if you click toward the top, you want to have a very positive response. Now, since then, some games have done a little bit of this. So, Mass Effect does a little bit of like a positional semantic correlation in its dialogue system. But this was trying to be a lot more than that, right? This was trying to be analog. And in each of the corners, there's some text exemplifying, like, if you went way out to that extreme, what would this mean? So if I gave a very positive emotional response, here's some text that would, oh, that looks really great. And if I gave a really intellectual negative response, this was actually the thing that he gave us as part of his submission. The intellectual negative response is like, I don't see any innovation in this game. Where is it, right? So it's easy to say, so his design goals were, let's have this expressive way of interacting with the AIs that gives you these analog choices and analog responses. And if you want to believe that, it's very easy to look at this game and believe it. Like, look, there's the input mechanism. You can click anywhere in this analog thing. But if you really end up believing that, then you have a faulty inverse conveyance skill, because there's a lot of problems in this. The biggest problem is a human interface problem. It's really not that possible to think in an intuitive way along these 2 dimensions. Maybe if you trained yourself to do it for a while, you could do it. But if people are just reading some dialogue and they want to respond, they don't really know where to click in here, and they have to think about it a long time. And so what they end up doing is just picking a quadrant that has the text that they want. They just look at the text and say, I want to say, how does this work? And they go click in the upper right quadrant, which is exactly the thing that you would do in an old-style game where you were just presented with some number of dialogue choices. So from a user interface standpoint, the innovation doesn't actually succeed, right? And then from an implementation standpoint, it didn't succeed either, because the AIs were, they had to be, their responses and their dialogue had to be authored by designers, and those designers had to write scripts to do that, and the scripts had to have discrete decision points, like, I'm going to give response A if I feel this way, or response B if I feel this way. And the way that it made those decisions was just by chopping this quadrant up into areas, right? And the most intuitive areas to chop it up on was just the quadrants. So it turned out that the scripts were just responding to the quadrants anyway. You could make the scripts respond in that kind of way to subquadrant areas or little circles in here or whatever, but then that becomes very unintuitive to the player because now there's suddenly invisible zones that they trip across and get a dramatically different response, right? If I click at x equals 0.7, that means one thing, but if I click at x equals 0.7011, then that means something very different with regard to the AI. So it would have required a much deeper implementation to actually succeed at making this interface work. But if you look at it, it looks like it works. And you can give a demo to people, and if they don't think critically enough, they're going to believe whatever you say about this, right? That happens in academic AI all the time. So to sum up, I've already said this, but to reiterate, good conveyance is more important than being a good programmer or designer or artist or all of those at once, because it will help you go in the right direction. Whereas with just those skills, it's easy to go in the wrong direction. Okay, so rewinding a whole lot, I mentioned that I was going to talk about two different guiding skills, and conveyance was just one of those. And the second one that I'm going to talk about, again, I term pushing, and again, that's something that I just made up. But I made it up so that I can talk in a concrete way about something that people really only just have intuition about, usually. Pushing is the art of understanding what the potential promise is of your game design and following through to reach that potential. It involves not just looking at the easy conclusions behind your design idea, but to find things that are not obvious, right? So one example, this is going to be a really stupid example because I'm making it up right now, but say I have this game idea, I'm going to make an action motorcycle game where you also fight people with martial arts. So you do a backflip off your motorcycle and you kick them in the head like in Mission Impossible or something, right? Well, what are some easy conclusions of that? Well, there's going to be other guys on motorcycles and I'll fight them and maybe they can jump off and kick me. Well, if that's all I make in a game, then there's a certain way in which that is uninspired. Like if a player sits down and they understand through the introduction, oh, this is an action motorcycle game, they're going to be able to think exactly the thing that you just thought. Oh, I bet there's other guys on motorcycles who jump off and kick back at me, right? So therefore, you're not giving them any kind of surprise or anything new or anything deep. You're just giving them the obvious thing that they already would have thought when given the premise, right? And then there's another aspect of this, which is just that often the first thing that you would think of tends not to provide the deepest kind of interactivity because it resembles the more common things that you've seen in other games. That's kind of why you thought of it most readily. Whereas if you hunt further and deeper, you can find things that are less intuitive, but that'll affect your players a lot more. So my canonical example of not pushing is Prince of Persia: Sands of Time, which was developed by Ubisoft. This is an action platforming game, kind of like my game, but it's in 3D. You jump over things, you fight guys, and this is a very blurry screenshot that I pulled off YouTube because all the static screenshots I could find didn't have the HUD. There's this HUD on the upper left corner, and that golden bar on the left represents sand, which in this game you use to reverse time. So if you get killed or you're not happy with how your progress has been going for a little bit, you can press a button and rewind time for 10 or 15 seconds and then redo what you just tried. And you can jump better this time, or hopefully you're in a safe place and can think about what you're going to do next. That was a pretty cool thing for them to do. It was a decision that had a lot of potential, but unfortunately they didn't follow through. They didn't push on that potential and get where they could go. Now, it was a relatively successful game in terms of revenues and marketing and stuff because it had this new feature in it that a lot of people thought was cool. But what's the potential of this feature? Well, if you can undo when you get killed, that's almost like a word processor or something when you make a mistake. It takes away the consequence of death, but there are some positive aspects to that. In games all the time, we get killed and we're like, oh, I have to go quick load now, but I haven't saved for 15 minutes and I lost 15 minutes of my progress. Or a lot of console games have automatic save points, but I'm not happy with how far away the last save point was. Or maybe the save points happen too often and it's slowing down the gameplay because I'm hitting the disc all the time. There's all these cumbersome things that happen due to this mechanic that we've become ingrained in about killing the player and letting them reload, right? Well, in this game, we had the potential to get rid of all that and just say, anytime you die, you rewind. And the only time you ever need to save and load is just when you want to quit your session. And maybe we have some autosave sometimes, so if you lose power or turn off the console, you don't lose everything. We can get rid of all this bad feeling, cumbersome interaction, but they didn't want to do that. And the reason why they didn't push on that, well, I don't know exactly, but there are some obvious reasons why you wouldn't, which is that if you take away all the consequence for death, then the whole premise of this game goes away. This game was about trying to make jumps that are hard to make and not fall in spike pits that'll kill you, right? Because it's bad to die. It's about fighting guys, well, and not letting them hurt you, because it's bad to let them hurt you and kill you, right? If you take away that part about it being bad to get hurt, then there's no tension in the game anymore, right? There's almost no reason to play the game. And the problem is that we're ingrained in decades of this kind of game design that takes this kind of challenge for granted. And especially for a game like this, it has a big budget. If you start talking about, well, for this game to reach its full potential, we have to change everything about it and make it unlike any game that's ever happened before, nobody wants to hear that. The board of directors of your company doesn't want to hear that. Investors don't want to hear it. So that's probably why it didn't happen, or maybe they just never thought of it, right? So these bubbles on the left represent how many times you can rewind before you run out of sand, and then once you run out of sand, you die just like before, and you have all these cumbersome problems. So the game design actually got more convoluted, because you have all the traditional ways of dealing with death, and then you have this sand thing on top of it. It's just like more complicated and weird and icky. So one of the premises of my game Braid, which I didn't show you, was that I said, I'm going to push there. I'm going to say the power to reverse time is going to be unlimited. You can never die or lose this game. And what does that mean in terms of game design? Well, this kind of threat challenge has to go away. That's scary. What can I do? How can I make a game that will be interesting to play now? But instead of being scared of that, right, because in indie I don't have to protect a big budget and recoup millions of dollars, right? I had the liberty of saying, I'm just going to think really hard about this for a while and have faith that I can come up with a way, if I think hard enough, to make this game interesting while maintaining this ease of time reversal and this generosity of it. And I did, and what I did was I eventually ended up making it into more of a puzzle platformer than a platformer, right? There's almost no action elements in my game. It's all cognitive. And so the interesting parts happen in your brain, not in your reflexes. I think I'm going to skip this, because it's beating a dead horse. Mr. Robot's a pretty fun game by a developer called Moonpod, and I'll give you the very short summary of this. It has sort of two game worlds going on. There's this game world where you're a robot walking around and you can push blocks to solve puzzles. If any of you are familiar with the old game Sokoban, it's kind of like that, but with nice graphics and a wider variety of puzzles. And it's got this story that takes place in this world, so you meet characters and talk to them, and that's all very nicely integrated and cool. But then they have this other world, which is this Final Fantasy-style JRPG combat thing that you get when you hack into computers, and it's not a very fleshed out game, and it doesn't interact with the main world very much or very well. And so I don't want to go too much into the details, but this isn't. Here's like your Final Fantasy style combat in an art style that's kind of hard to decipher with your eyes. But those are the player characters on the left and the enemies on the right. And this is just somewhere where they really should have pushed more and made this gameplay more interesting and interacting more richly with the main world, or else maybe they should have cut it. And I can see why they wouldn't have wanted to cut it, but it really feels empty, and I think it drags the game down. It would have been a much more compelling game if it were just the puzzles. But it's a good game, and you guys should all go at least play the demo. Okay, so the analogy that I want to bring up for pushing here is that you're searching around with your game design, trying to find some treasure, and you're walking on some, mountain path next to a wall, and there's a little, shiny trinket there, and you're like, aha, I found the treasure, I got it. But it's just this little necklace, and if you just had turned and noticed this wall and pushed really hard on it, you would have found a secret door where there's a big treasure chest inside, right? That's what we should all be aiming for, and it's out there, but so many developers just don't try. So to finish up with pushing, the pushing attitude is to not accept your game just because it's a successful implementation of what you set out to do, right? When I was talking about conveying before, or inverse conveying, right, was making sure that what you're making is what you wanted, right? And so you can be successful at that, and that's a necessary condition probably for a great game, or it's helpful. But it's not sufficient, right? Because something could be a successful implementation of what you wanted to do, but it turns out that what you wanted to do maybe wasn't as great as you thought it would be when you get there, right? So you want to have the willpower and the freedom to reject your game, or some portion of it, because it doesn't feel as compelling as you would imagine. Because if you try to accept it and just work on it incrementally, you can improve it a little bit, and asymptotically approach some level of goodness eventually. But it takes a lot of work. But if you reject it, that gives you freedom to go somewhere else and find something else to put in your game design, right? And just like rocket through that and get up to a whole different level of quality. And the last thing I want to say about this is that pushing really is a skill. It's not just something you decide to do and you're automatically good at it. Like, you can't just be looking at your game and go like, I'm not satisfied with this. Aha, I've got this brilliant other idea. It takes a lot of practice and like mental gymnastics to figure out what those other ideas feel like and to recognize them when you catch a glimmer of them, right? So this is something you learn and practice and build over a course of years, which, when you think of it that way, it's not really surprising that we see a lot of people new to games who fail in this direction, because you can't really expect people to have this skill. Okay, so the way to summarize all this conveyance and pushing that I've been talking about is that the first one sucks, by which I mean, if it's all that you can do to barely get your game done, which is a very common thing because games are hard and they take a lot of work. If you can just barely get it done and out the door, it's not a very good game. Sometimes people do that and they think that their game is really good, but in practice they're fooling themselves, right? Their inverse conveyance skill is broken, and the game isn't as good as they think. And sometimes that's not true. Sometimes you get lucky, but it really is luck and not development skill. So independent developers and students do this all the time because they're both low on resources, right? Students have classes, they have all this stuff going on. They probably have to do a game in one semester or 1 year. Indies don't have that much money, maybe they're working a job on the side, and so they get to some point where the game is playable and they go, that's it, that's the game. But that's not the right decision almost ever, right? So my game Braid was fully playable from end to end in December 2005. I submitted it to the Independent Game Festival and won an award with it, right? So somebody thought it was good. But it's still not done now, 2 years later, because it just takes a lot of work to get a game to the point where it's fulfilling its potential. So, not to beat the horse too hard, but to say it again in a different way, your first playable version is not your game. They're not even necessarily very closely related. Your first playable version is just a starting point that you want to get to. And once you get to that starting point, you can push off it, right? And you can use your conveyance skills to guide yourself to a much better place that's maybe far away from your first playable version, but that realizes the potential of your ideas. So, when I say it that way, that sounds depressing to a lot of people because they're like, well, man, it's so hard even to get to that first playable version. You're telling me that that's not good enough and I have to do all this other work. Well, the rest of this talk is about how to make it less work to get there, so that's not so bad when you have to push past it. And the first step in this process is acceptance. And I'm going to talk about what that means in terms of being a designer or an artist or a programmer. If you're a designer, accepting the fact that you're going to have to push past your initial design means that you're going to have to change your idea of what the core gameplay is, right? If I'm making that motorcycle action kicking game where I'm going to backflip off the motorcycle and kick somebody in the head, maybe after building it I realize this game just isn't that fun. Like, it's hard to aim at the guy, and because I'm backflipping, like my camera's rotating all over the place and I get a headache just playing this game. The game mechanics are all there just like I wanted, but I don't want to play my own game. Like, what's wrong here, right? But then you think, oh, maybe if I made it a turn-based strategy motorcycle kicking game, then I would have a lot more time to think about how high I'm going to jump and what angle I move my leg at, and that could be compelling. It would be like, capoeira chess on motorcycles. That's how you get really interesting game ideas that nobody would have thought of. And part of this is to not be too stubborn about your own design ideas. You want to let yourself be guided and realize that you're actually being guided by your own ideas and the results of your own ideas. So it's okay. It's still you coming up with things. But look at your game and listen to what it's telling you, because your game knows itself better than you do, right? So the last thing is to be prepared for a lot of detail-oriented special case design. Once you finalize the main design, you're going to start looking at little pieces that are not satisfying. So in my game, I all the time had things where there's a puzzle you can solve, and the players had fun solving it, and they all kind of liked it. But once in a while, I'm trying to walk through this part of the map, and a monster comes at me, and I try to jump over him, and I hit my head on some corner in the geometry, and it feels bad because I bounce off over here, and I as a designer didn't want that to happen in this puzzle, but it happens because of this arrangement of objects. And so now I need to go back to that and revisit it and think, do I want to move all these objects? Maybe I can't, because maybe the puzzle is very delicate in terms of timing or in terms of distances. And then I have an even harder problem. Do I want to restructure the whole puzzle? Do I want to cut it from the game? Do I leave it and leave this uncomfortable spot in there, even though I know it'll degrade the initial play experience? There's a lot of thinking that goes on, all after you have your initial game done. So in terms of art, sometimes it's even more frustrating than that, because art objects are so concrete. You've built some meshes or drawn some texture maps or some bitmaps. The first phase is to do a lot of that creation, understanding that it's all temporary. You do, what we call pre-production, which is where you just experiment all over the place and see how it looks and see how it feels. You try a lot of alternatives, and eventually you pick one, and you know that all these other things you tried, you're going to discard. And you try it. You don't just maybe sketch concepts on paper. You start that way, but you do it to the point where these things are actually running in games sometimes, and you can experiment with them and compare them, right? So that's the first thing, is to understand that a lot of the early work you do is disposable. But it's disposable for a good reason. It helps make the game better. It's not just getting thrown away. But then later on, a lot of the things that you thought were the real art for the game also need to get thrown away. Because of that way that I mentioned earlier, that programming and design and art are all intertwined, sometimes late in development, there'll be a design decision or a programming decision that means that the art has to change. Sometimes the art has to completely change. I know you made 7 different dogs to be pets in this game, but now the pets all have to fly. And we can't have flying dogs because they would be too big, so you need to make falcons and stuff like that, and we're going to throw out the dogs. That is very frustrating as an artist to deal with, but it's a necessary part of the process. It's part of what makes the game good. So you have to understand that your role as an artist is to help guide this game to where it's trying to go. It's not the creation of these specific objects, because if you become too attached to the objects, you'll be really frustrated when they go away. In terms of programming, again, the mindset of throwing things out, right? Be prepared to rewrite subsystems several times to make them faster in different ways, or to make them have different functionality, or to just completely get rid of them because they no longer apply, right? You also have to be very productive. There's a lot of different ways you can be productive. Some of those ways are things like always program the simplest thing possible and don't put in more effort until later. There are things like don't ever spend time debugging unless you have to, right? Some programmers spend 60, 70, or 80% of their time debugging and very little time writing new code. That's very inefficient. So there's another skill that you can learn. There's a couple of skills. One is you can learn how to write code that doesn't have bugs. It's a certain way of structuring programs, of developing incrementally, right? And after a while, after about, I think, 7 or 8 years of game development, I got to a point where pretty often I was writing things that would work the first time. And I was like, wow, this is really cool. Because back in college, I had this impression that really nothing would ever work the first time unless it was devastatingly simple and not even worth thinking about. But in fact, you can get to a point where complicated things will work the first time. That's a really good place to get to because it really helps you prototype and explore ideas, right? Another skill you can build as a programmer is knowing the cause of a problem, like a crash or a corruption, before you ever even look in the debugger, because you know what you just programmed. So you should have running in your head ideas about how this can interact. You definitely know how this is supposed to interact with the rest of the program, because that's why you put it there. But you should also have ideas about maybe how it could badly interact running subconsciously, right? And when a crash happens, you go, aha, I bet that's because I didn't check the value of this variable in this function over here. And you go look in the source code, and what do you know? That's exactly the problem. And you never had to even perform an investigation or open the debugger. That makes you a lot faster. I program in release build most of the time. I don't even ever compile a debug build unless I have to, because it takes time, and I don't want to spend it. Maybe I'll get to this in the remainder of the talk, but don't fall in love with complicated code. A lot of programmers start programming because they like technology and they like building things that are challenging. If you build things that are challenging, your game is going to get bogged down in technical difficulties, and you're never going to be able to achieve the design or the artistic potential of the game. So especially if you're a Renaissance indie developer, meaning you're doing a lot of these jobs at once, then you need to create a style of programming for yourself that is very easy. It needs to not tax you mentally. You need to be able to get an idea for what you want to program, and then just sit down and type it in without worrying about it. It needs to be a low-energy task, and the reason why is if it's not, it'll eat all your time and effort. There's so much programming involved in making a game already. Even if it's easy, it's going to take most of your time. If it's hard, or if you're setting up challenges for yourself because you like challenges, then you're never going to get to the rest of the game. It'll never get finished because the programming will just expand to eat everything. And a more subtle issue is it'll dominate that mixing process that I mentioned earlier. Remember how I said, design changes can affect art and can affect programming. If your programming is really cumbersome and hard to make changes because there are all these big, complicated systems, then that means if you have a trade-off between design and programming, and the design issue is really important, and it means that you should make a programming change to support that design issue. But that's in a system that's really complicated, and every time I've changed that in the past, it generated 50 different bugs, and it took a week to get it nailed down again, and that's going to be a big can of worms. You know what, screw it. We're not going to change the program. We're going to change the design. And that's not the right decision in this case, but we had to do it because the programming forced us to. This happens all the time. I'm sure some people in this room have probably seen this happen. You don't want it to happen. Okay. I'm going on an hour, but I'm going to zip through these last few points. There are things that distract us and kill our games or force the development to be very inefficient. And there are things that we're taught in school or that we learn in industry, and they're good habits to get over. One of them is way too much 3D. This is especially true if your goal is to make a game that's interesting to people. 3D is not helpful. There's all these studies that show that if you sit somebody down in front of a 3D game, they have trouble manipulating the camera. They have trouble figuring out the spatial relationships between things, especially if they're trying to move and jump. 3D opens up a lot of problems, but we're indoctrinated into making 3D games because that's what's been successful in industry. As young people growing up with video games, those are the games that excited us. But you know what? They're much, much harder to develop than 2D games. That's why I made my game 2D, because I wanted to focus on the things that were important, the design and the aesthetics, right? Not the technology. Now, if you're an indie with a low budget, or you're a student team and you make a 3D game, what's going to happen is you don't have the resources to make the 3D really nice, so it's going to be kind of clumsy, and it's going to be kind of ugly, and it's going to take all your time, and you're going to be disappointed in your game. But schools encourage it, and, certainly companies encourage it, like still very few large developers want to make 2D games. There are exceptions sometimes, especially with Live Arcade, but it's a problem, and there's no need for it anymore. Like my game, even though it was 2D and I kept the technology simple, it still took 3 years. It's not done, and it's the 3-year anniversary of this game. So don't underestimate the power of 3D to kill your productivity. And I'm saying this like, I'm not just some guy who only understands 3D a little bit. I have 12 years of experience making 3D games. I used to write a technical column where I would explain to people tricks about doing interesting stuff in three dimensions. And I just said, forget it. It's not worth it. So I encourage you guys to think about that. Because again, 3D seems glamorous, but when you look at the reality of what you're going to be able to do in terms of meshes and animations, it is not glamorous, right? It sucks. So don't do it. The second thing that gets in the way all the time is ludological hermeneutics, which is my sarcastic way of saying that there are game design people out there, entire schools of thought, that have this culture of making big words and stringing them together into sentences that are impenetrable and that just make you try to think that those people are smart, but you can never understand what they're saying. And some designers out there actually think about their game designs this way. And there are merits to these words. I'm not trying to say that these are bad words. Hermeneutics is a great word. And sometimes you need a big word to explain something subtle, but you never need to make a sentence out of 20 big words and force somebody to try to read that. Maybe this doesn't work as well in Danish because you guys have some big words, but in English words are short. And the other thing is, if you have these very dogmatic ideas about your design and you're enforcing them in terms of navigating your design from place to place, it means you're telling what your game to be and you're not listening to what it actually is, right? And as I was just saying before, listening to what your design is a very important skill toward building a quality game. And so the way that I feel about these schools of thought is that they create these very mental constructs that are very distanced from reality. They don't have very much resemblance to me to the things that I encounter from day to day when I'm developing games. So I encourage people to ignore this stuff at least until they become very experienced in the day-to-day workings of how you make a high-quality game that is compelling to people. And then the last thing, and this is going back to the programming issues that I was talking about before. Everywhere, in schools, industry, everywhere, we have this culture of over-engineered program structure, like class hierarchies, like everything is abstracted. You have to call a function just to know what the value of a variable is. That's bad. It creates a lot of extra work, and it doesn't do anything. There's this phenomenon where somebody will sit down and they're going to start to engineer their program, and they make a I'm going to have this class, and this class is going to inherit from that, and this class is going to be a friend, and these guys are going to talk through this pipe to this other thing over here, and they get very excited about that, and they map all that out. But in the end, it's just a class diagram. That's still not a program, right? It doesn't do anything. It's just some boxes, right? You have to sit down and make something that does things. And when you start getting into here, C++ is a really horrible language for this, even though almost all high-end games are written in C++, including mine. Because when you start doing this kind of stuff, it really slows down your compile and link time, which means that every time you want to make a change, you now have to wait forever to see the results of that change, and it really slows you down. It's like programming through molasses, and you have a higher probability of encountering compiler bugs because the process of compiling is so much more complicated. My philosophy here is that if you ever need a class diagram, whatever you're doing is too complicated. So on the left is I found that on the internet somewhere, but it's a class diagram auto-generated by something that obviously didn't do a good job. But even if you did a good job of visualizing it, it would still be too complicated to really understand. On the right, this is the most complicated class diagram that I ever have in anything that I program now. It's just sometimes I have a base class and something inherits from it, the end. Often I just don't use classes at all. No, seriously, because there's honestly not a benefit to it. That's something that I've found. And that's a very controversial thing. A lot of people disagree with me. But my official opinion, and the opinion of a lot of my friends, is that classes are pretty harmful most of the time. And this isn't strictly true because really what you might see is a row of boxes. So I might have a resource manager being the top box, and then a few different resource types inherit from that, like texture maps and audio files and stuff. But if you design that top class that it doesn't have any static data or any kind of data sharing or communication between the children, then you don't ever have to think about the fact that more than one guy inherits from this unless you're making major code changes. And so that's why I feel justified in drawing it as two boxes like that. That's all that I have to say today. I have a URL at the top here where you can go This started out as the blog just for development on my game, but it's turned into a place where I post about all sorts of interesting games and design issues. And I also have different lectures like this, but with different content posted there with slides and audio that you can download. And then the bottom is my personal page where you can find some prototypes of games that I've developed and just some other links to interesting stuff. And thanks for your time. Do we have announcements, or do we want to do any questions? Or? All right.
Should we take the questions before? Or we can take the questions with food. Okay.
Yeah.
I might not stay at food very long is the thing. So, yeah, I have somewhere I was going to go tonight. But
yeah, any questions?
We'll do a couple questions really fast.
Yeah.
Hey, I have two questions that are not really related to what we were talking about today.
Okay.
The first is, you said that you found your games doing like contract work and previously, like how much do you split your time between doing your own game and earning enough money to actually do that? If you sometimes have the feeling that it gets too much?
I don't recommend trying to work on a contract simultaneously with a game because it does get in the way. I've done that a few times and I've always been very unhappy because you can never focus on what you want to do. You end up doing not as good of a job on the contract, which can be bad for your reputation, right? And also not as good of a job on your game. So what I would recommend, the thing that I did before this game was I did a pretty large contract that was made a lot of money, right? It gave me enough to live for a couple of years without having to work and to pay somebody for at least a year, year and a half to work on the art. And then eventually I ran out of the money, but the game was far enough along that I was able to do some contracting, and it was frustrating, but the game was far enough along that I knew that it would get done. So I didn't feel so bad about spending that time in the other direction. But in the very early stages of your game, you run the danger, if you're trying to do both things at once, of your game never taking off.
Okay, can I ask that question as well?
Okay, fast.
Okay, very fast.
Yeah.
Like a lot of indie developers, they work as a group, like as a collective or a team.
Yeah.
And with your games, I have the impression that you try to like have this mental image in your head, and then you try to find people who can help you, like the guys that are. Is that not on purpose, like why you did that, or is that the problem? Like, how can you motivate yourself, like working like alone until you have like?
Well, yeah, my preference. I don't like team dynamics very much because for a lot of reasons. One is I'm just fundamentally not a team player kind of personality, but also my goal is to express things that are very intimate and personal. You know, maybe not even in an emotional way sometimes, but also in an intellectual way. Like, everybody thinks different things are intellectually interesting. And when you've got a team of people, they never quite share your vision, right? And so I think that you start running the danger of seriously diluting what you're creating. In this case, I was lucky that I wasn't equally partnering with someone. Like, I'm paying him to do the art, so he kind of has to do what I say, even if he disagrees, which is fine. A lot of people can't do that, and so they have to work on a team, and I just say, well, do the best you can. Some people like to work on teams, right? But my preference is that I dictate what the game is, and I dictate how it's going to get where it's going to go, and then if I need people to help, then I find them. But that's, yeah.
I think there was one question up there.
Yeah.
You mentioned your game a few times.
Yeah.
I was just wondering if you could, in a few words, describe what's special, what's new about your game.
Okay. Yeah, so it's an action platformer. Were you here when I showed the screenshots? Were you here when I showed the screenshots of it? Yeah. So it happens in a world like that. Like Prince of Persia, you can rewind time. At the beginning of the game, though, you go through this process of learning the game as you play, right? So shortly after learning how to jump and stuff, you learn that you can reverse time anytime you die, and that it's unlimited, right? So that's the first thing that's different. But again, that's not super different. By itself, that might be enough for a kind of interesting game. But like I was saying, I wanted to push beyond that, right? After that, you journey from world to world, and actually the mechanics of the way time behaves change from world to world in a way similar to, I don't know if any of you have read the book by Alan Lightman, who's a physicist at MIT. He has a book called Einstein's Dreams. which is an homage to Italo Calvino's book Invisible Cities, in which he's visualizing Albert Einstein thinking about all these different ways that time can behave. It's sort of like that. So you'll go to the next world after you've learned that you can rewind, and in this world there are some objects that are immune to your rewind power, which is weird, but it also ends up setting up some very different puzzles. And so then what the game is about is showing you these puzzles one by one and saying, hey, do you understand this consequence that naturally arises when some things are immune to your rewind power? Do you understand this consequence over here? And so it's almost like showing you things one by one, kind of like that Mr. Hart game. And then it goes on. There are different things like that Donkey Kong looking level that I showed. The reason that that's a hard puzzle is that in that world, time is tied to space. So it doesn't move like time is still if you're standing still. And if you walk this way, time goes forward. If you walk this way, time goes backwards. So everything in the world is kind of in sync with your motion. And you have to start thinking about phase in time and space and how they interact. And so even though it's a puzzle game, the puzzles have a very different nature from other games. And that was a long explanation, but sorry. Okay,
One last
one.
question.
I just wanted to ask if you could make this presentation available online.
Yes, as a matter of policy, I always do. It may take up to a week before I do, but if you go to this top URL, it'll be posted there. All right, thanks. Announcement.
Thank you again. Thank you for coming.